Hello, Matrix, and welcome again. Today, I'm going to be showing you optimization. So what I've done is I've broken optimization into 4 simple steps, and I'm going to talk you through each of them today, and then we'll do a question, and this should hopefully make it more clear. And then in the next few videos, I'll be doing some more optimization questions just to reinforce it. So here we go. Here are the 4 steps. The first thing you're going to do is you're going to get a function. And so this could be a profit function, or it could be a height function, whatever function it is, and you need to get it in terms of one variable. In other words, if it's in terms of x, it needs to just be x's, or if it's in terms of time, it needs to be just time. Then what we're going to do is we're going to find a derivative for that function. And then the third step is we're going to make that derivative equal to 0. And finally, we'll substitute the answer that we got in the third step back into our original equation to find your maximum or your minimum. So those are the 4 steps, and let's see how they work with a question. All right, so we're given a question here where we've got a semicircle and a rectangle, and we're told that the rectangle, the perimeter, is equal to 60 meters. Okay, now we're also told that this side is B, which means we know that the other side is also B. Okay, so this side is also B. And of course, if this is R here, the radius of the circle is semicircle is R, then this is also R. And so, of course, this at the top, because it's a rectangle, is also going to be 2R. And finally, we know that the semicircle is going to be, because we know that the semicircle is equal to, the circumference is equal to 2 pi r of a full circle. And so a semicircle is going to be not 2 pi r, but just pi r, so half of that. And so all of these, the b, the 2r, and the pi r are going to add up to 60. So let's just write that down, because we want an expression for b in terms of r, and we've got r's and b's here, and of course we know that that's 60. So the full perimeter. So we're going to say 2r plus 2b. Well, let's make the pi r first. 2r plus pi r equals, plus 2b is equal to 60 in total. Now, what they want is they want b in terms of r, so only b. So what we can do is we can say 2b equals 60. We're going to take the r's across, so we can say minus 2r minus pi r. Divide that all by 2, and we get now an equation for b in terms of r, which is 30 minus r minus pi over 2r. We've divided everything by 30. So that is our 10.1 done. Okay, so that was the first bit, and that is going to be where we start our steps. And so the first thing we're going to do is we're going to find the function in terms of one variable. So they want to know the value of r, which will give the area of the stage a maximum. So what we need to do, if they want to know where the area is a maximum, we're going to find a function for area. So our step 1 is we're finding a function. In this case, we're finding like an a of r, right? Because it's in terms of the radius. So a of r equals, and it's going to be something with just r's in. Okay, so we need a function for area. So simply just go and say, well, what is the area? So we've got this rectangle is part of the area. So 10.2, okay, we're doing this function in terms of one variable. So we're saying the area in terms of r is going to be b times 2r. Well, that's going to give the triangle, but of course b is not r, and we want it only in terms of r, but we know that b in terms of r is this. So instead of putting b here, we can put 30 minus r minus pi over 2r. So we're going to, this is now our b. So because we were told in 10.1 to get a function for b in terms of r. So b is actually just 30 minus r minus pi over r. So I'm going to use that, pi over 2r, sorry. I'm going to use that, and then that multiplied by, of course, 2r, because that is going to be the thing. And then what we're going to have to do is we're going to add the area of the semicircle. So we're going to add the area of the semicircle, which is the area of a circle is pi r squared. But of course, the semicircle is going to be pi r squared, but it's only going to be half of that because it's a semicircle. So plus a half pi r squared. Now, let's times this all out. So AR equals, and then 30 times 2 is going to be 60R. And then R times 2R is going to be minus 2R squared. And then pi over 2R times 2, the 2's cancel. And so we say minus pi R squared plus a half pi R squared. Okay, so now we've got an equation for our area, which we can then find the derivative of. So, here we go. We've got okay, we do need to do it in a different color now. So, find the derivative, which we said is in green. So we've done this blue bit here. Now we're going to do the green bit, the derivative of the function, which is a dash of r equals 60 minus 2 times 2 is 4r. 2 times pi is minus 2 pi r. And then 2 times a half, well, that's going to be just 1. And so that's going to be plus pi r. Right, now what we can do is we make this equal to 0. So we've done this. Yep, we've done that. So we'll say 0, oops, in yellow now, because we're making it equal to here. So 0 equals 60 minus 4r minus 2 pi r plus pi r. Well, minus 2 pi r plus pi r is just minus pi. So we get minus pi r. So we get, let's get all the r's on one side. So we'll take all the r's to the right-hand side. So remember, these two sum to minus pi r. So when those goes across, so let's do it on the other side, we'll get plus pi r on the left-hand side. And then when we take the minus 4r across, it becomes plus 4r. And that is equal to 60. Okay, now what we can do is we can solve for r. We take r out and then we say r plus 4 equals 60. Pi plus 4. And now we just divide both sides by pi plus 4 to get r by itself. And we get r equals, and we put that in our calculator, 60 divided by pi plus 4 equals 8,4, 0. And that's going to be in meters. Now what we do is we've done that, and now we can simply substitute that back into the original. So we'll say area, when we put in of 8.4 as our r, equals, we're going to say 60 times 8.4 minus 2 8.4 squared minus, okay, these, well, let's just put them in pi, 8.4 squared plus a half pi 8.4 squared. Okay, and we just put that into our calculator. And when we put it into our calculator, we get 252.2 meters, and that is going to be the area of the stage squared. Okay, so there we go. Those are the 4 steps for optimization. We're going to be doing a few more videos with optimization, so we'll go over this if it didn't make sense the first time. What I did here, by the way, is this would have been the answer for 10.1. This R equals 10.2. Now what I did is I added in another question because I wanted to show you all of the 4 steps, okay? But sometimes they don't ask you for the area, they just ask you for what the radius needs to be to get the maximum area. And then in order to get that maximum area, we have to substitute into the original. So well done for watching, and if you followed it along and were able to understand everything, very nicely done. If not, just watch the video again and hopefully it'll make sense the second time around. Please like, subscribe, and all that good stuff, because I will be posting more videos to help you guys through to your Matric final exams, and I will see you again soon.